Alhamdulillah, assalatu wassalamu ala rasulillah, assalamu alaikum wa rahmatullahi wa barakatuh. In our last class, we saw what is a vector and its magnitude and how a vector is represented geometrically. And we have another representation, or that are symbolic representation. Suppose a vector, as we have already discussed, that this is a vector being represented here. The length, say 5 meter. This length represents the magnitude of the vector. This length represents the magnitude of the vector, and the arrow represents the direction of the vector. There could be 2 points, point A and point B. And how to represent this vector? This is geometrical representation. By drawing, we see, by drawing a line segment with an arrow, we represent a vector geometrically. But if we have these 2 points, then we can also write this vector as A, B. And here there is an arrow over AB. This is also representing this vector, and this says that the initial point of the vector is at A and the final position is at B. That is, the direction of vector is from A to B. We can also write this vector as a small a or B, C, D, like this. So this is also a representation. And in books especially, bold capital letter, say this bold capital letter can also be used, but we are not dealing with the book and pages of the book, so we will represent vectors with small letters, with small single letters. So here we go. We will use this notation in our discussion, and these are the representation of vectors. But if we want to show the magnitude of vector, we have another way. These are representing vectors, but we have magnitude as well. And for magnitude, how we represent? We can take AB and close it inside bars. This is known as magnitude of AB. Or in similar way, we can write our small vector A, small letter A, and we can enclose it into bars. And this requires some extra work. So I will be using, for magnitude, AB. This represents the magnitude of vector AB, that is 5 meter. And also in small letter case, I will just write A, and you could also use these symbols. This means magnitude, that is the length of vector AB, and this also means the same thing. So if I write the letter with an arrow, then it represents the vector, and if I write just A or the letter only, then it represents magnitude of the vector. Hopefully, I think it is clear. Okay, now let us move to some operations associated with vector. And in these operations, we are going to study one thing, is scalar multiplication. Scalar multiplication. The second thing, the second operation will be addition of vectors. Addition of vectors. The third operation is going to be multiplication of vectors. Multiplication of vectors. In addition, we will combine subtraction, because both are same thing. Both are same thing. How? We will see it. And in multiplication, there are two main things involved which we will study in depth, and one of them is dot product. Dot product. And also in mathematical language, we call it inner product. Inner product. And the second kind of product is cross product. Cross product. or we also call it vector product. Vector product, and we will see what this means. So before diving into that, let us take some kinds of vectors, examples of vectors. There are certain vectors, for example, zero vector. Zero vector basically is a vector having no definite direction and zero magnitude. That is a vector, if we draw a vector which has length of 0 then and no specific direction, then it will be called a zero vector. And a unit vector, what is a unit vector? A vector which has unit length, say 1 meter. The vector having a unit length is known as a unit vector. But this is not, there is not much about this which I am going to discuss. I will focus on these operations. So let us move ahead. So let us dive into scalar multiplication of vectors. What we mean by scalar multiplication? Scalar multiplication. Scalar multiplication, we mean that, let's say we have a vector, and this vector we are naming vector A. When we multiply this vector with a scalar means a number, any number, say 2, then our new vector becomes 2 times of A. This is our new vector, say B. What it means? It means we have a vector B which is in the same direction as vector A, and it is twice in length. It is twice in length, that is its magnitude is 2 times of the vector A. So multiplying a vector by a scalar means it is being stretched. This factor, if it is 2, then the vector A is being stretched 2 times. If it is 3, then vector will be stretched 3 times. And if it is half, then the vector will be shrinked to half of A. That is, our new vector will be, say, like this, half A. So multiplication means stretching the vector. If it is larger than 1, say 2, 3, 4, 5, it becomes that times in magnitude, in length, but maintaining its same direction. Direction is not changing. And if this scalar is smaller than 1, then the vector gets shrinked, half, 1/4, 1/8, anything would be. And we also have a possibility of multiplying with a negative scalar. For example, minus 3a. Here negative 3, what it does, it stretches the vector A 3 times, but in opposite direction. That is, our new vector will be, say, like this. This vector B is minus 3a. What it shows? It shows that this vector minus 3a is in opposite direction of A, but having a magnitude 3 times. So there are some points we must remember. Point number 1, that multiplication or scalar multiplication stretches or shrinks the vector. If our factor or scalar is greater than 1, then it stretches, and if it is less than 1, then it is shrinks. And the second thing, this stretch or shrink can be or could be in two different directions, one in the original direction of vector A and the second in the opposite direction of vector A. If our scalar is positive, then what happens? The vector maintains same direction as original vector. But if this scalar quantity is negative, then the stretching or shrinking happens in opposite direction of original vector. In general, we can write scalar multiplication if we have a vector A, our given vector, then we can write another vector, say B, equals some number, some constant alpha times A, and this alpha is our scalar. Now this scalar could be greater than 1, which means stretching of the vector. This alpha could be less than 1, which means shrinking the vector. This alpha could be positive, that is stretching or shrinking in the same direction as the given vector, as in this case or in this case. And this alpha could be negative, it means shrinking or stretching of the original vector in the opposite direction, as in this case. So this is basically the multiplication or scalar multiplication of vector, and we encounter it often. We encounter it regularly in our physics study, so it must be clear in your concept.